Welcome, everyone. Thank you for joining us tonight for this exciting webinar on how to with your TI-Nspire CX2 graphing calculator, and it is part 3. During tonight's session, we will share with you how to find out part 1 and part 2 if you had to miss any of those, but thank you for being here. I'm Ruth, I'll be the moderator. We're going to be using the WebEx chat features tonight. If you're watching the recording a bit later, and yes, this is going to be recorded, you won't be able to interact with the chat, but we are going to be using this for questions and comments throughout the event. When you have a question or a comment, please select everyone from the drop-down menu in the chat. Why don't we go ahead and give that a try? Maybe chat out your name and your location to everybody. Just using the chat feature there. I'm going to take a second or two and scroll up and down. Look at locations. All right. Again, this will be recorded. Sometimes people choose to view Betty and Judy do their magic and go back again later and watch the recording or review some of the material and try some things again later. If you have any audio or video issues that cannot be resolved, please feel free to watch the recording a bit later. And let's just get right to it. I'm so pleased to have outstanding educators with us tonight, Betty Gasquet and Judy Hicks. Betty and Judy, thank you so much. Please say hi and tell us a little bit about yourselves.
Thank you, Ruth. I'm Betty from Charleston, South Carolina. It says on the slide there, but I've recently moved to Pawleys Island, South Carolina, which is only about 70 miles northeast of Charleston. I'm a mathematics educator, though I have taught some science in the past, and really enjoy working with teachers and their students using this wonderful TI technology.
Hi, I'm Judy Hicks, and I'm a math educator from Denver, Colorado. And also, just like Betty, I have used a lot of TI technology in my classroom, and it's always fun to share some of these things on webinars. And my only thing is, I am missing the Thursday night football game, so I'm hoping the Denver Broncos are going to do better. That's my hope. All right. So the agenda for tonight, again, we had the welcome and introductions. And as Ruth said, we encourage you guys to chat whenever you want to, whenever you need to. And one of the three of us, or we invite other people to respond. We are going to be looking at a math-inspired activity called Comparing Linear and Exponential Data. We're going to be doing some graphing of univariate data and looking at some various ways to show that. We will be using interactive math boxes. And then, of course, throughout the time, we will be using the CX Premium Teacher software. And then at the end, Ruth will go through some question and answers. We'll have a drawing and announcements and closing.
And we hope that after this evening, if you haven't had a chance to enter data in the list and spreadsheet application by entering formulas in the cells, you'll have a chance to see that and practice it later or practice it along with us. And also we're going to look at the use of some split screens because they can be very effective in comparing different data sets, but also in comparing different representations of the same data set. And we will also, as Judy mentioned, look at interactive math boxes. These are actually used on a notes application page in the TI-Nspire software, and you may not have had a chance to explore those lately. So we'll look at those tonight and hope that you can use those later with your students.
Thank you so much, Betty and Judy, and let's get started.
Okay, I'm going to share my screen, and we're going to look at the TI-Nspire Premium Teacher Software. And Judy and I are kind of tag teaming here tonight, and she will be chiming in as I move the software around and about, but we will also be both sharing some thoughts about things that we've done with students, as Judy said, when we've used some of these activities. One of our favorites is a Math-Inspired activity, and we'll show you where it's located at Math-Inspired after we explore it a little bit. It does have a TI-Nspire document, which I'll show you in just a moment. It also comes with a student activity and teacher notes. And the student activity actually poses this question. Now, before we get started on this, because clearly this is graphing linear and exponential data, we'd like to ask you to chat and tell us just briefly what types of graphs of data you've had your students create or that you've explored and plan to use with your students this particular year. So what types of graphs of data do you either use now with your students or do you plan to use this particular year? And Judy, I'll let you share some of the chat as it comes in, if you will.
Okay. Linear quadratic regressions from Josh and all parent graphs, Gary, and again, more linear quadratic exponential scatter plots. Kind of a wide range. Again, some of the same. Exponential, natural logs.
Okay, so sounds like a lot of bivariate data, a lot of graphs of data. And so that's where we're actually starting tonight with data that we're going to look at some graphs and compare these graphs. And this particular problem is one that many of you have probably done with your students. It involves the little prize where you're going to have one prize that begins with $10 and increases by $5 each week. And then another prize that begins with a penny and doubles each week for 16 weeks. And we all know if we've done this with our students that they really can't believe how quickly the one penny grows and grows and grows into much more money as it goes along. But what we wanted to do is share this with you. And also, in case you haven't used these methods to enter data, that's the big focus. We know you've probably done this problem or one very similar to it with your students. But the TI-Nspire document that is provided to use with the students does have the problems stated again. So students can look at it here or in the student worksheet that I just showed you. And it also actually has data entered. The week number starting with 0, the adding column, and the doubling column. But what we'd like to do, and especially those of you who'd like to button punch along with us, which is not necessary, as Ruth said, this is being recorded, but we're going to start a new document. And if you're going to button punch along with us on your handheld, then just go ahead, if you will, and press the home key and select new, and it may say new document depending on which version of the software you're using. So you can either arrow over and click to choose that or just press the number. And I wanted to make sure that we see this. For those of you fairly new to the software, if a document was already open, and this is true in the handheld, of course, as well as the software. So if the document was already open, then we would need to choose no if we don't choose to save the previous document. So I'm going to say no, and we have a new option here, and I'm going to select add list and spreadsheet. Now, of course, we could just press the number 4, but often when we're doing this with students, I have found that arrowing to the number helps them focus on where I'm going, as well as slowing me down just a little bit. So we're choosing add list and spreadsheet. So right now, we're going to go ahead and name these lists. And
why do we have to name them, Betty?
Oh, that's a great question. If you do not name the list, you can still enter the data. You can still do cell manipulations, as we'll get into, as far as putting formulas in cells. But if we, for example, I'm going to delete this in just a minute. Suppose we had some data here and we wanted to graph it. It would not let us graph it if it did not have a name. So the data will not graph unless the lists are named, so that we can choose a list as the independent or dependent variable if we're going to graph a scatter plot.
I asked that because sometimes kids do that. They, put the data in, but then they forget to name it.
Absolutely. And I've done that myself. I've just entered the data happily and gone to do a plot, and it says no data is available. So thanks for bringing that up. So if you choose to abbreviate, that's great. But I'm going to name this one weeks. And of course, with the software, I could just type that on my computer. And we do go to the very top of that list to enter the name. And then sometimes students forget to press enter or the down arrow to actually store that name. And then we had a column for adding, and I'm just going to put add. And again, they would have read the information before they come to this. And another adding, another column where we were doubling. And we could just abbreviate DBL, or if you are a quick typist like your students with the handheld, you could spell it out. And again, I could do this on the software just by typing on my keypad as well. Now, we're going to stay out of this formula row right now. We'll use it again. We'll use it later this evening. And I'm going to enter the 0 here, starting with week 0. And we have to press enter to store that value. We started with $10 for the first prize type. And we started with a penny for this prize type. And it's always nice to have that 0 to call attention to the decimal, but notice when I enter that, it stays with us, which is nice. Okay. And if you're typing along with us, everyone doing okay here? Now, if we're only going to 16 weeks, or at the beginning, just going to 5 weeks, because they ask in the student activity that we just go to 5 weeks, which would actually take us to the 6th row, then the students could just type it in. They're pretty quick, but we wanted to discuss some other methods with you tonight. So if I type the number 1 here, I've got a beginning of an arithmetic sequence, of course, and we want that sequence to continue for the number of weeks. So this is what you can do. We could have put in a sequence command, but what we're going to do is hold down the shift key. Now, clearly I can't type right here and hold down the shift key and also use my down arrow. You can do that on the handheld. On the software, I'm actually holding down the shift key, and I'm going to hold it down, and it always behaves funny here sometimes, and highlight both of those cells. Well, I've done that 10,000 times. Here we go. Oh dear, oh dear, oh dear. Well, it will work, but never when you're on video. Okay. Judy, have you had that experience too?
Oh, sure. Hold down. Are you holding down your shift key on your computer?
Yes.
Or on
yes. I am on the computer, and I've done that multiple times.
Oh, yeah, I know.
All right, so we're going to show another method here, but it will work, I promise. And I've done it on the handheld multiple times too. So what I'm going to do here is actually put in a formula. What I would like to do is have this equal, and we have to use our equal sign, cell A1 plus 1. So that obviously gives us our value 1. Now, if you simply highlight the cell that has the formula in it, we can go to menu and choose data and go to fill. Works just like with a spreadsheet. Menu, data, fill. And now notice what happens if I arrow down. I'm getting these little dotted outlines. So I'm going to go to row 6 and press enter. So that fills in the data for the first 5 weeks after the initial beginning. So it's a really nice thing that students can do. And also in the adding one, I would do exactly the same thing. I'm going to start with cell B1. Prize was to add $5 for each week. And Judy, do correct me if I'm incorrect about that. And once we have that formula in the cell, we simply go up again. We go to menu, data, fill, and again, arrow down. You'll see the little dotted lines. If you go down too far, you just arrow back up, press enter. So there's our prize when we're adding $5 each week. Now, one more time, except this time we're putting in a formula for doubling. So we're starting with cell C1. and we're going to double, multiply by 2, enter. Now, this is easy on the software, but not as easy on the handheld. You can grab that little cross, I guess I would call it, hold down the left click of my mouse on my software and drag that down, again, just as you would on a spreadsheet. Have to be a little bit careful, it's sensitive, not to go too far. So that works as well. So that's another way to handle it. Anyone questions to there? And I was holding down the left click of my mouse. Okay, so as we see, the students would certainly think that this was not a really good thing to do, because if they chose the doubling, because after the 5 weeks, we only have 32 cents versus the $35. And you all know the rest of the story. Now, they asked the students, of course, to consider that, and then they asked to go on into the 16th week. So again, I could hold the left click of the mouse and pull down with any of these, but sometimes with the handheld, I think it is easier to go to menu, data, and do the fill. And that works extremely well. And then they just simply arrow down. And by the way, you can fill down or fill across, either way. And if we want to go to 16 weeks, then of course we have to go to the 17th row. And we just simply press enter. And we would do the same thing for these other data sets. Now, the directions on how to do this are in the teacher notes. All of these wonderful math-inspired activities have teacher notes. They give possible solutions for the student questions, and also they give some tech tips and teacher tips to go with the lesson. So again, this data was all provided in the TI-Nspire document. If you choose not to have the students enter it, just to use the document, that would be fine. But we wanted to make sure you had the opportunity to see this wonderful opportunity to fill. When we've got arithmetic or geometric sequences, clearly it works very well. So we have our data now, and we're going, and there's a question, can we highlight and do 2 columns at once? That's a great question. Let's see. So your question would be, if I wanted to highlight both of these last 2, for example, let me know if I'm misinterpreting that. And so right here, if I held down the shift key that time, it worked perfectly. And let's see what happens. If I highlight those 2, and that was just holding the shift key on the computer, which didn't seem to want to cooperate at all earlier, and I go to data and fill, let's see what happens. We should definitely have $95. Let's see if it seems to work. Perfect.
Hey. Yep.
And that's the best thing about this time of webinar. You all come up with things that perhaps some of us wouldn't have thought of. And I'm going to go ahead and just type the 17 here first time, because that's wonderful. So we could have done all of them at once. I learned something new about this technology every time I'm with teachers. Thank you. So the idea now in the activity, and again, those directions on using the formula in the cells are in the teacher notes. The idea now, of course, is to see things have gotten more exciting with the doubling. We knew that as educators, we knew what would happen. Think about if you're teaching Algebra 1, this is a great way to develop linear relationships and then move into exponential relationships. We've got repeated addition, we've got repeated multiplication, we've got our initial amount in each case, thinking about y-intercepts. So it's a lot of wonderful teachable moments throughout this activity. But what we're going to do now is add a data and statistics page by pressing Control followed by Document to add a page. Now, there are other ways to insert a page, but that's the way the students seem to find easiest. And we're going to add a data and statistics page. When you add a data and statistics page, the list shown here is the first list alphabetically. And it does not mean that you can only graph the addition list. So when we say click to add variable, of course, you as teachers know we're talking independent, dependent variables, etc. And it gives us all of the lists that have been named. And thanks, Judy, for bringing that up again. We're going to go choose weeks as our independent variable. And students learn that they can simply press tab to move to choosing another variable over here on the handheld. It's easier to click on the software. So I'll choose the additive relationship first. And as we expected, linear, but students may not have expected that. We would ask them to predict before we graph, of course. Now, here's the fun part. And this is already set up for them in the TI-Nspire document. So if you're using the TI-Nspire document, the data's already there and we've got the split graphs. But in case you haven't split graphs yourself, we wanted to include that. We go to document, which has lots of interesting things in it. And one of them is page layout. Now we're going to choose a layout. Custom split allows you to do perhaps 2/3 of the page on the left, 1/3 on the right. But when you go to select layout, there's some preset layouts. And I have done this on a handheld. And even though you've got less real estate space, obviously, for the screen, it really works well. So we're going to choose layout 2, which is the vertical layout. And notice that we need to click on this side. Right now, the left side is active. So if I click on the right side and choose add data and statistics again, we can graph our weeks again as independent variable. Click over on the vertical side and choose the doubling data. And clearly what we want students to see, that rapid growth with our exponential relationship, the constant growth with our linear relationship. Now, several of you at the beginning mentioned regressions, but in this case, students hopefully would be able to determine the relationship because we're starting with the 5 and we have that constant additive. So if you want them to graph the relationship, notice I've clicked on the left side, that's highlighted there. I can go to Menu, Analyze, and look at the options in Analyze. And even though regression is there, one is plot function. So if the student should be able to determine the function, thinking about the characteristics of a linear function, then perhaps we want them to determine it themselves rather than going straight to regression. So this allows us to enter a function. We started with $10 and we had that constant additive of $5 for each week. So it's a really nice way to introduce these types of relationships with the students in Algebra 1. And we could do the same thing on the right-hand side. It would become F2 of X on the right-hand side. So I wanted to go ahead. We didn't want to spend too much time on this problem since many of you have probably graphed a lot of data, but we did want to stress the entering the formulas in the cells and also splitting the screen. This activity is from Math-Nspired. Just go to education.ti.com. Under Activities, Math-Nspired. It's in Algebra 1.
Are you showing that, Betty?
Oh, I thought that I was. Let's see.
I think it's you're reviewing or you're sharing the application.
Yeah, let me try
before.
sharing again my screen. And earlier, when we were looking at this earlier, it seems to be jumping back and forth, and this time
There we
it's
go.
not. Okay,
There we
so
go.
we went to Activities, Math-Nspired, and then under Math-Nspired, we went to Algebra 1, Exponential Functions, and there it is. And you can download teacher notes, student activity, and also the student activity comes in Word document form in case you'd like to edit it. Okay. All right, so Judy, if I do this now, am I back to the software?
You can click back on it.
Okay.
Well, try it.
I did. Okay, that worked earlier when we were doing the preview about an hour before we started, but this time it decided not to. So we're back now. I know I can go back this way. Okay. All right, so the next thing we're going to look at fairly briefly is some data that can be displayed through box plots, histograms, or dot plots. And if you'd like to type along with us again, you can start a new document. But another alternative is to go to this document option and insert a new problem. Now, we'd like to insert a new problem so that if there are any variables in problem 1, they will not show up in problem 2. And so as soon as I choose a list and spreadsheet, you will see that I'm in problem 2. Alternatively, you could have opened a new document, but if you want to keep all of your data explorations together, again, those variables that we had in the previous problem, problem 1, would not show up in problem 2. And that's especially nice if you're going to do functions in both of them and you want to start with f1 of x again. So I went to document, insert, problem, document, insert, problem. Okay, now we'd like to have some data to explore. And I don't want to ask you to sit here and type in lots of data. And a lot of times with students, you don't want them to sit and type in data either. And in Math-Inspired, Judy and I are always talking about the wonderful data sets that are there. If you want students to look at data that they have not collected, real world data, obviously you could have them collected. So what we're going to do, we're actually going to generate some data using a random number generator. And I'm going to just name this scores for test scores. And obviously you would normally be entering your own test scores in here. But to save us from entering data tonight, we don't want to sit here and type in 30 or 40 scores. We're going to choose some random integers. Now, I'm going to go to the catalog, which is to the far right of the number 9. And if you're at the letter A, which you likely would be at the very beginning of the catalog, if you hadn't been there lately, you press the letter R for random to get down to random. Now, I'm going to show you another step in just a second, but this is the command we're going to use, random integer. Notice it wants a lower bound and an upper bound. And when we look at anything with a bracket, that means that is going to be optional. If I did the lower bound was 50 and the upper bound was 70 and did not put a third value, then it would just give me one random integer. So if I click to choose that, I'm generating a random integer. And to get some test scores, let's just type 60 for a low score. Pretend the test could only score 60 to 100. The comma's down in the bottom left-hand corner. 100, and this is inclusive, 60 to 100 inclusive. Do another comma. And suppose we want to generate 32 test scores. So the syntax again, low number, high number, inclusive, and the number of scores. And then we press enter. Now a warning, if you're going to have every student generate some random numbers, you want to be really, really careful, because if the calculators have been recently reset or they're brand new, they will all get exactly the same random numbers. To alleviate that issue, you simply insert, and you would really do this before you generate the random numbers. Insert a calculator page.
Although sometimes it's good to not do what you're going to do here until and it's a good discussion with kids as to why did we all get the same numbers.
It's wonderful. And for those of you, and I know there are a few on the webinar tonight who have been around about as long as I have, you remember the old days of opening up a book and closing your eyes and pointing at the random numbers. Now we have all of these wonderful tools to use, but we don't want most of the time the students to get the same random numbers. So on a calculator page, you simply go to menu, come down to probability, where we would expect random things to live, come down to random, and choose seed. And if every student types in a different number, I tell them to put the last 5 digits of their telephone number, see how long it takes them to figure that out, and then press enter. So that starts the random generation process at a different place for every child if they pick different numbers. Sometimes I even have them pick the same numbers and see what happens. And if you needed to redo this, you could. But right now, I've got random test scores. Now, what we're going to do here is a little bit strange, but we're going to go up where we generated these, and we're going to delete that. Notice it did not delete the data. But
And why are you doing that?
Exactly. The formula is controlling this data. And once we graph this data, we might want to manipulate it a little bit, and you'll see how we do that in a moment. But if we had not eliminated that formula, these would be controlled by the formula, and we would not be able to control them on the plot. And thank you for that question. I always wonder if I'm going to have to press the equal sign. But if you start typing here, and notice if you know it's RANDINT, you don't even have to choose it from the menu. Up here in this column, it will take care of the equals. However, if you're in a cell, as we were earlier, and you start typing A1 times whatever, it will not work unless you put in the equal sign. Thanks very much for bringing that up.
Good question.
Yes, absolutely, Deborah. Thank you. All right, so we're going to graph these data. So I'm going to press Control Document, add a list and data and statistics page. We've got our data. We're going to graph it. And when we click here, we only have the one test, one list, so we just choose scores. Notice the default is a dot plot. Now, there are ways to change that. And one way is just simply to right-click on an empty space on the screen. With the handheld, right-click is Control followed by Menu. But it's easier for students perhaps to go to Menu and choose Plot Type. And I'm going to choose Box Plot. And notice if we simply hover, I'm not clicking on anything, I'm simply hovering, we can see the 5-number summary. Now, let's chat a moment. Probably not all of you teach box plots, but if you do, and sometimes students have to interpret them on state test, whether it's in, what you would normally teach every year, what problems do they have interpreting them? What difficulty the students often have when asked to interpret box plots?
Yeah, just chat it a little bit. You don't have to write everything out, but what kind of mistakes and stuff do kids make? Yep. If it's skewed, good. What else? Middle 50?
Yeah, and understanding quartiles, yeah. Remember, I've chose 32 pieces of data. So a lot of times students think there should be more data in this larger section, which I think is what some of you were getting at, right?
Right, exactly.
Jane just chimed in with that as I was thinking it. And about outliers, of course. Great, all sorts of things. Now, what we're going to do with this one to continue our theme of maybe a few different things is to go to, excuse me, let me press escape. We're going to press our document key and go to page layout again. And we're going to choose select layout. And this time, instead of going vertical as we did earlier, we're going to go horizontal. So that's the third layout choice. Now, this time we're going to need to press the menu again. And at the bottom part of the screen, we're going to do another data and statistics graph. And by the way, there's a wonderful activity called Box Plots Introduction. It's in the files that will be provided for this webinar when you look at the recording area. And it does all of this that we're about to do. So here I'm going to go ahead and choose the scores again. And that's kind of an interesting plot. We would ask kids to predict it before we actually graph it. But what's really interesting to me about this is that if I go and click in a region in the box plot, it highlights the dots, the data points that are actually graphed there. and it highlights them in the other plot. And you can actually hover, not click, but hover over any of these dots and see that particular score. I usually get exactly 8, but sometimes it could be 7 or 9, and I imagine you can certainly figure out why that could happen. I'm going to click in an empty space to deselect. Notice if we click another section, same thing happens. So it's a really, really nice visual. And then one other little things I want to mention, because someone in the chat a few minutes ago talked about skewed left or skewed right. You know, obviously we've got a lot of information about the data with the quartiles, the median, but we don't know where the mean is located, even though you could probably do a pretty good guess. So if you haven't seen this before, I think this is an interesting thing. If we go and click in the upper part of the screen, make sure you're in the box plot region, and we're going to menu, back to analyze again, which has some really nice features. But one of the features that you may not have tried is plot value. I'm going to click to choose that. And the V1 just means the first value. Now, on the TI-Nspire, one of our luxuries is that we don't have to go find things in the menu or the catalog all the time. I could go to the catalog to find the word mean. But if you know that you need the word mean to find the mean of a data set, you can just simply type it out. Notice right now, those letters almost look like they're in italics. As soon as I press the letter N, it sort of straightens up. This is a command. I'm going to do the open parenthesis. Now I need to put the name of the list because we want the mean of the list scores. But if you have a very long list name and you don't want to type it, you press the variable key, VAR, and you can select that list because you may have 4 or 5 different lists and you only want a particular one. Or you could have typed scores and then press enter. So that gives us the value and the location of the mean relative to the median, which again, for those of you who teach statistics in high school, we often have to talk about this when we're talking about skewed left, skewed right. So I think it's a really nice visual to have. And if you wish to remove it for some reason, we can simply right click, which again, control menu on the handheld and remove that plotted value. I really like that. You could also put it on a histogram, of course. So what we're going to do next, and I just want to take a few more minutes with this because we've got some excitement with our notes page that we mentioned early on. I'd like to go ahead in the upper part of the screen here, change the window settings. So we can go to Window, and since our maximum value was 100, I'd like to make the maximum X value 150 to leave us some space to work with. And then we want to do exactly the same thing in the bottom part. But before you go to the menu for the bottom part of the graph, be sure to click in this region to move the focus to this part. Kids are really good at that. They're big mousers and clickers. And then we go to menu, window settings again, and change the maximum to 150. I just kind of picked 150 arbitrarily. We may need more, but it may work. Now, someone in the chat earlier mentioned outliers. And one of the neatest things here, we can control this data. Remember, that was the reason to take away the formula. The formula is not controlling it. And we can actually, when you see the open hand, you either hold down the left click of your mouse if you're on the software, or you press Control click on the handheld. Control click on the handheld, and you can grab a data point, see it move in both locations. And this is a great exploration of kids to see when a data point is an outlier and what the mathematics behind that is to make it become an outlier. I mentioned interquartile range earlier, so we can talk about that interquartile range multiplied by the 1.5 and see that distance. So it's a really, really nice visual for them. And this data point will also have changed in the list. Notice has a decimal, and originally we did not have any data and the list that had a decimal. And now we certainly will. I can locate it. Yep, there it is. So these are connected. As long as we stay in the same problem, everything is connected. Anyone questions there? Thoughts, comments? We could also, if we choose, convert one of them to a histogram, and then you could let kids think about what kind of information does one plot give that the other does not, and vice versa. So it's really, really nice to be able to compare these plots. And again, I love being able to put the location of the mean on there using plot value. So again, that was menu, analyze, plot value. And you can control the bin width. Whoops. By the way, students do this all the time and they panic. Go back to the current document by picking that fourth option, and there we are. So you could also put the location of the mean on either plot. Okay. All right, so this activity, which will also be in your folder of activities, has up the plots for 28 heights of students, and you can investigate that. We hope you'll look at that later. All right, so Judy and I wanted to be sure to have enough time to spend on something that we weren't aware of in the very, very early days, and then we really became very fond of. And this is called using interactive math boxes in a notes application. But before I move to that, there didn't seem to be any other questions in the chat. Just wanted to make sure before moving onward.
Right.
Okay.
And how many of you just in the chat put yes or no if you've used math boxes?
It's not related to this activity. Okay, so most people not yet. Okay. All right, great.
All right.
So to move into math boxes, what we're going to do, I'm just going to open a new document and to do a new document, and we're going to add notes. And of course, most of the time, probably as you imagine, the notes are used for things like the first page to write a note or the second page to give a note. And they really are very often used that way. But if we're going to use the math boxes, we're actually going to go to the menu, and there are interesting things in the menu. One of them is actually some templates if you were going to include some really short questions in a document. But we're going to go to insert, and notice that not only can we do math boxes, we can do chem boxes, which allows the chemistry people to write H2O, for example, as it looks or as it should look. You can insert shapes like triangles or circles or whatever. So I'm going to choose number 1, but notice the shortcut for math box is Control M. So, but right now we wanted to choose it from the menu first. So, and notice it just doesn't look too exciting, but there it is. So one way that Judy and I always introduce this is that we just look at Pythagorean theorem, for example. Now we're going to define a variable, well, an assignment operator, right, Judy?
Correct.
We're going to press a letter, your choice, and then press Control followed by the template key. That's immediately to the right of the number 9. It's a colon followed by an equals, and you could type that on your computer if you're on your software. And we're simply going to assign a value. So A is now 3. Notice when I pressed enter, it opened a new math box. We'll assign another one, Control, template 4 for B. And now we're simply going to define C. And that's Control, template, and we'll use the square root, Control X squared, and just simply type A squared plus B squared.
And notice they do go bold because they're defined.
But the neat thing about this is now, and Judy and I have noticed that whenever we look at ACT and SAT type things, they talk about Pythagorean triples sometimes being so important. Anything you edit will affect anything that has that variable as part of its formula or its relationship. So now we're exploring Pythagorean triples, for example. So this is something that we can do. And Judy and I like to look at some other things. So for example, I have to click inside of this math box to use it again. And Judy, what is it you call these math horrors or something like that?
Algebra atrocities.
Algebra atrocities. I knew it was something that was really exciting. Many of us have asked students to square A plus B. Notice I have to right arrow to get out of those parentheses. And the little darlings who do not think carefully or did not pay attention often think that this is what they should have. And notice I did not use the assignment operator this time. I just started typing some expressions so they can quickly see that something's wrong. And so they can look at some of their math atrocities, which is pretty fun. And the other thing we can actually do, and I'm going to just take a minute, I hope, for this, is to go and do control right parenthesis. And I'm going to put in a number and a comma and get rid of this one over here. And notice we're putting in 2 values for A. So now we're getting 2 values for everything that involved A. So you could do that with B as well. But the important thing is that anything that changes, everything else related to it changes.
And this is the reason we're doing it this way instead of just using the store.
Yeah.
Because it allows us to do what Betty's doing and everything changing accordingly, which of course store would also, but it's a whole lot easier as she's showing you.
Exactly. So now we want to move into our optimization problem as advertised. And this is a quote from Euler, a Swiss mathematician many of you are familiar with. And if you think about maximum and minimum, lowest gas price, best test score, on and on and on and on and on, we really do look at maximum and minimum a lot. And unfortunately, before the advent of these wonderful calculators, a lot of those wonderful optimization problems were only for the calculus students because they were using calculus to determine the best or the least or the most or whatever. We used to have a terrible joke in the olden days, and some of you are too young to probably appreciate it as much, but we used to say that Euler was the only mathematician that had an American professional football team after him, named after him. But unfortunately, the Houston Oilers changed their name, and that took care of that. But the Swiss used to put him on their 10 Swiss franc bill, so that was pretty good for a mathematician. So we're going to look at minimizing the sum of 2 distances. And this is a problem many of you have seen before, I'm sure. And I don't want you to have to do all of this reading, but it's the old classic. You've got 2 towns, and you've got to put a pumping station on a river to go to both of the towns. And you really want to minimize the amount of material that's got to be used to build this pumping station. So it's easier always to see a picture. So here's the lovely river. Here is town B, which is 9 miles directly from the river. Town A, 14 miles, distance between A and B. And we want to put the pumping station at point B so that we're minimizing the distance to those 2 towns. And of course, it could go over here, but that doesn't look like it would be the best option just visually. So this is the problem we're going to deal with. So to set up the problem, we need to know the distance from O to C. And the numbers were chosen very carefully. And obviously, I made this in miles and should have made it in kilometers, but that could be changed very easily. This is a geometry page, and you can always change the scale. But for right now, let's look at what students might do to determine the distance from O to C. Notice how well the numbers were chosen. So this is a perpendicular. Should have put the little perpendicular symbol there. So we know we've got 5 and 9 to make the 14. And we've got one of those exciting right triangles. So that gives us the information here. And of course, we would let students work with that. So we've got that distance, which means we have this distance. I think one of the hardest things for my students used to be to think about, if this was X, what was this? The old 12 minus X would drive them crazy.
Yep. Or they'd write X minus 12.
Yes, yes, yes. So now we know if we want to express the distance from A to D, we've got a right triangle because this was perpendicular, this was perpendicular. So now we're ready to use our interactive math boxes. And this document is in your file folders if you'd like to use it with your students. So this is a notes page that has been added. Now, if you're using the non-CAS software, which I am tonight, and you want to enter a value for X to get started, and you want to put in this relationship X squared plus 14 squared is equal to this quantity squared, we have to give X a value first. It needs to have a variable value. So I'm going to start with X and assignment operator and just start with 6. Why? Because 6 is midway, no other reason. And notice what happened. Judy, what did I do wrong there?
I don't think you have a math box.
Exactly. I tend to do that. Got to remember to insert that math box. Shortcut was Control M. So if you don't see something interesting and colorful happen, then you know you forgot your math box. So we just started halfway from O to C, right there. Now, what I want to do next is, and I know I'm going back and forth, but I want to find this distance from A to D using X and 14. And I have it written on a sheet of paper, so hopefully it'll be okay. Now you can abbreviate a lot, but if you're on the software, and I need to open up a math box again because I went to another page and that threw things off. All right, so I'm just going to call it distance AD. And you can abbreviate it as much as you'd like to, of course, if you're on the handheld. Control followed by the assignment operator. We need the square root symbol. And this was 14 squared. Judy, do help me if I mistype, which I immediately did as soon as I said that. 14 squared.
Plus X squared.
Okay, plus X squared. Thank you. And notice the X is bold, as Judy said earlier. Okay, so that's the distance if X is 6 going from A to D. Now, if I press enter, I did not pick up another math box. That's strange because we did before, but we know Control M. So this time it would be the distance from B to D. And I do the assignment operator and the square root. And this time we had 9 squared plus the quantity 12 minus X. And get out of that right parenthesis, move out of the right parenthesis, and proofread a little bit. All right.
Yep.
So those are the individual distances if X is 6. And then we want to have the sum of the distances because that's our quantity to be minimized. And we're going to maybe just put sum and this. Oh, can't use sum.
Nope.
Because that's what's the word I'm trying to use?
Defined.
It's an operation.
Defined.
It's a defined operation. Like we could not use mean, M-E-A-N. All right, I'm just going to put sum D for some distances. And control assignment operator. Now here's where your variables come in great. You don't want to have to type all those out again. So we press the variable key. Those are our variables so far that have number values. I'm going to pick the first one, put a plus, go back to variable, pick the second, save some typing, and then enter. So at X 6 miles, at 6 miles from 0, that left-hand end, or letter O, we've got our distance of 26. Now we could go up and change this just simply to 5 and see if that's better. Don't think it is it? Because that's 26 more, where this was 26.0. So this is where, and Judy always reminds me about this, it's a wonderful option. This is where the braces, control, right parenthesis, and putting in several values just to see what's going on. I'm going to do 6 and 7 and also 8, pretty close together there. Now, let's focus right here. 26.0, 25.94, and 25.97. So it looks like we're better between 7 and 8.
Yep, getting smaller.
Which would allow us now to go back and do a little editing here. And notice we're just doing a delete. And we could do now a 7.5. We sometimes call this bracketing and halving, H-A-L-V-I-N-G, in other contexts. Be careful with your commas. So now we can look again and see what's looking best. So 9481, 9447. So then maybe we want to look more in some of these other areas between 7 and 7.5. So it's really nice for students who are able to think about data and analyzing data. I think as soon as we got graphing calculators, we went heavy graphing, but sometimes we don't back up and think about the students having to deal with spreadsheets in the business world and go back and revisit data as much as we could. Now, if you do like to do the graphing, I went ahead and included that. Oh, and someone, the comment just made about the guess and test. Yes, that's a very powerful thing, and particularly with students taking standardized tests. And they've got such intuition about things sometimes, and we don't think to go try those methods because we grew up on algebra, and plus we're very good at algebra. So thanks for making that comment. But if you are accustomed to graphing this type of thing, we could graph it, find a window that makes sense. You'd have to play with the window a little bit. And for those of you who've done the analyzed graph and done the minimum, that's certainly still an option. And if you had not seen this, we just do a left boundary of the minimum and a right boundary. But what's interesting here is that it's rounded just to 1 decimal place. But if you had not seen this, be sure to show your students. You can hover over either the X value or the right value. And on the handheld, just simply press the plus key. Now I'm going to press the plus key on the computer and notice that more digits are displayed. And so they could compare that to what they did with the interactive math boxes. And around 7.304, and remember we were thinking between 7 and 7.5 somewhere, and we could have gone back and changed this to 7.2 and 7.4 and played onward with it. So that's a nice feature. Now, if you decide to look at this problem with students, I drew it with a smaller scale here. And there's a wonderful, that wonderful book with the Orla quote that was called Max Men Without Calculus, talked about this problem. And Heron of Alexandria, who was very interested in all sorts of mathematics, but also mechanics and optics, Heron did the simplest method of all. And I realize time is really getting tight, so I'll try to go quickly here. And Heron just simply went to, he drew this and he did a reflection. Think about optics. He was interested in optics. He reflected this point about that line. So we have B prime. And then he said the shortest distance between 2 points, as we always say as well, is a straight line. So the segment from A to B, and there is the location of the pumping station, because we know this location to B prime is the same as this location to B, so we have our shortest distance. And since this is done to scale, students could measure that after they find the intersection, and intersection is one of our options here. So there are obviously lots of ways to work this, and many of you may have worked it other ways, but Judy and I just thought it was a neat problem to bring up in the midst of sharing with you about the math boxes. And students really, really enjoy those.
And Debbie asked a question about if math boxes could be used to compare the equivalence of expressions for identities. I mean, you can use math boxes just about for anything. And
Yes.
and the kids, they're once they have things set up, then it's just easy to put those values in and compare.
One danger I want to warn you about, though, and this has happened to me. Suppose that you're going to look at trig functions like sine of x and cosine of x and
Oh,
see
yeah.
if sine
Yep.
over cosine is tangent. If you start typing, I'm going to insert a math box. If you start typing, for example, sine of x,
Right.
x is not defined. Now, that would be okay on a CAS machine. It would just return sine of x. It wouldn't give you an error. But you might want to, first of all, go to your beloved pi and store it or something. If you're not on a CAS machine, store it for x first. And then, whoops, I did that backwards, didn't I?
By the way.
And that's trying not to keep you late here on a Thursday night. But if we define our x, first of all, on a non-CAS machine to be a value, and notice how it went back now and evaluated sine of pi. But again, on the CAS machine, you would be okay just starting with your identities, your trigonometric identities or whatever. That's a great idea. Other thoughts, comments, or questions?
Back to you, Ruth.
Okay, thank you. Thank you so much. I think I'll say this on behalf of all of the attendees. We don't mind going a couple minutes over because we were enthralled and we can't wait to try it some more on our own. So thank you. The chat is still open if you have questions or comments to share with Betty and Judy. And in the chat, I sent out a link to the documents for tonight's webinar. You will also be getting those in an email. Follow-up registered attendees will get that email. And chat's still open if you want to share some comments. Webinar drawing. All right. I used my random number generator on my TI-Nspire handheld. Thank you, Betty. And tonight's winner is Yun Lin from New York. You will be getting an email from somebody related to scheduling these webinars, and they will let you give them your information about which calculator you choose and where to send it. So congratulations on that. Okay. Documents, I sent the link out previously. I'll send it out now while I'm talking about it. You will also get this in a follow-up email, and it's also available when you go online to view that recording. It's called on-demand viewing of the webinar. And then the last order of business tonight, a link for tonight's certificate of attendance.
There you go,
That
Josh.
link. That link has gone out in the chat. You will also get that in a follow-up email.
Oh,
Okay,
and
so you
Ruth,
can,
Ruth,
yes.
may we apologize to Josh about the Edmonton Oilers?
You certainly may. Right.
The Broncos are up 3-0.
Oh. All right. Well, thank you so much. Check boxes. We've recorded it. We've sent out a link to documents. We've sent out a link to certificate. We've selected a winner. And oh my gosh, you've certainly given us a lot to think about tonight. Thank you
Thank you
so
so much,
much.
everyone, for your chat and participation. It was great to
Yeah.
be with you.
Thank you.
Thank you.
Good night.
Good night.